Hello and welcome to this film, which is all about acid deposition. Now, acid deposition is slightly different to acid rain, and we'll look at why. A lot of people would call it acid rain, but in this film, most of all, we're going to look at how rainwater can become acidic on account of some non-metal oxides in the atmosphere, and how hydrolysis equations can help us explain the acidification of rainwater. And we're also going to look at where these gases might have come from and how we might prevent them from entering into the atmosphere. Now, first of all, we're going to have a look back at this list of important acids that we saw right at the beginning of the topic. Then you can see that lots of them are highlighted in blue here. The blue ones are the ones that are relevant to acid deposition. Okay, so just have a quick look there. They are the ones that we're going to focus on in this film. And we're going to have a look, first of all, at the difference between rainwater that is acidic and acid rain. Now, all rainwater is acidic, and that's because all rainwater comes into contact with carbon dioxide in the atmosphere. And if you combine the atoms for carbon dioxide and water, you form this acid, carbonic acid. So this is quite a simple equation to write. If you know the formulas of carbon dioxide and water, just add all those atoms together and you get the formula of carbonic acid. We should be able to explain that carbonic acid will react with water to produce H3O plus ions and hydrogen carbonate ions. So these are just hydrolysis equations like the ones we've seen before. We know that carbonic acid is weak, so we'll have two-way arrows here. We know that it's diprotic, so hydrogen carbonate ions will react with more water molecules. But the key thing here, I suppose, is to realise that without writing these equations, we can't show how this carbon dioxide actually made the rainwater acidic. Okay, so it's these ions and their presence in the rainwater that makes it acidic. Now, having said that all rainwater is acidic, let's have a look at what we mean by acid rain. Now, acid rain is rainwater that is so acidic that it's more acidic than carbon dioxide could have made it on its own. Right? Now, how could rainwater have become more acidic than that? Well, it might have dissolved some other non-metal oxide, and in particular, we're going to look at the oxides of nitrogen and sulfur. Now, nitrogen, you might remember, has a triple bond in it, okay, which means it's a very unreactive gas, but when we burn things in car engines and other high temperature environments, we can sometimes get nitrogen to react with oxygen, in which case it will produce nitrogen monoxide, and nitrogen monoxide will react with more oxygen to produce nitrogen dioxide, okay? And this is going to be a really important oxide for us in this film. Sulfur. Sulfur is another substance that we can end up combining with oxygen when we burn things. That's because it's present in a lot of fossil fuels. So when we burn the fuel, we end up burning the sulfur as well. And we're going to form two really important oxides here. We could form sulfur dioxide, or we could form sulfur trioxide, which would be formed if the sulfur dioxide that we'd formed here reacted with more oxygen in the atmosphere. Okay, so having had a look there at the three oxides that we're going to be most interested in, let's see how they're going to make rainwater acidic and produce acid rain. Now, acid rain, by the way, is just one form of acid deposition. Acid deposition refers to any time when these acids that are in the atmosphere make it down to the surface of the earth. Okay, so this might happen by rain, it might happen by snow, it might happen by sleet, it might happen because some solid particles brought these acids down to the surface. But anyway, let's have a look now at how sulfur oxides could make rainwater acidic. And in the first place, we're going to look at the reaction of the sulfur oxides with water to produce acidic substances. So sulfur dioxide could react with water to produce sulfurous acid. Sulfur trioxide could react with water to produce sulfuric acid. And once again, these equations are quite simple because all we have to do is add the atoms up and we get the products. Having done that, we can then have a look at our two substances, sulfurous acid and sulfuric acid, and show them reacting with water molecules in the rain to produce H3O plus ions, okay? So again, we're showing how it is that they're making the rainwater acidic. And I'm not looking at these hydrolysis equations in too much detail because we've seen lots of equations of this type before. Now let's have a look at some nitrogen oxides, and in particular, like we said, nitrogen dioxide. A little bit more complicated, the equation here, because we can't just add nitrogen dioxide to water and get the products we want. We need to take two nitrogen dioxide molecules, react them with water in the rain, and we get nitric acid and nitrous acid. And again, writing the hydrolysis equations for these two acids should be quite simple, bearing in mind one's strong, one's weak. And again, we can show H3O plus ions forming in the rainwater. Now, let's have a look at how we might prevent these oxides from getting into the atmosphere. Now, we're not looking at nitrogen oxides here. We're looking at sulfur oxides because that's what the syllabus tells us to do. Okay, and we're going to look at two different ways of preventing these oxides from entering the atmosphere. We could do it by using something called a pre-combustion treatment. And as this suggests, this happens before we've burned the thing we're burning. So before we burn the fuel, we might remove sulfur from it. If there's no sulfur in it, then we can't make any sulfur oxides and we're going to prevent them getting into the atmosphere. We've got to do that before we burn the fuel. So you might have seen some low sulfur fuels available in petrol stations. You could do it after you've burnt the fuel, but of course by now you have made the oxide. So here's some sulfur dioxide that perhaps we made by burning some coal perhaps that had sulfur in it, maybe in a coal-fired power station. And what are we going to do? Well, we're going to react it with something. Okay, now we know this is an acid, so let's react it with a base here, like calcium carbonate or a carbon. Well, I suppose we're not familiar with seeing this as a base because it's not an oxide or hydroxide, but it reacts with acids. And as we know, acids react with carbonates to produce salts. So here is a salt, calcium sulfite, and water and carbon dioxide. So if we can pass our oxide over something like limestone, which has a carbonate in it, and here is a fairly cheap, readily available material that will react with our acid and prevent it escaping into the atmosphere. Okay, so that was a quick look at some oxides that can cause acid deposition. Hopefully it all makes sense. If you've got any questions or comments, then please feel free to come and see me or to post a comment on YouTube.